Here's your Pre-Calc 10.1.4 mini lecture, part 1. It's about parabolas. It says in previous courses you worked with parabolas. By definition, a parabola is a set of all points that are equidistant from a fixed line, a directrix, and a fixed point, a focus, that is not on the line. In this lesson, you will use the definition to construct a parabola with your team and write the general equation algebraically. You will take a closer look at a parabola and discover a property of parabolas that makes them extremely useful in devices such as high-powered telescopes and satellite dishes. So it always has you start out by like doing a little discovery. Maybe you're going to try to, figure out the graphs of these things. I'll remind you what we used to know, or what we probably still do know about parabolas. We already knew that it's a quadratic, and we can write it in graphing form as y equals a times x minus h squared plus k, where h and k are the vertex of the parabola. A is the stretch factor, h, helps you find the horizontal shift, and k helps you find the vertical shift. So if they give me a parabola like this one's actually going to be a sideways parabola, because this is the y squared is the one that's squared. So even if you don't remember about graphing form or anything, you can always just plug some points in. When it's like this, I usually will plug the point in for y and then find out what x is. Like I plugged a 0 in for y, and then that zeroed it out. So I know there's a point at 0, 0. I'm picking points to plug in for y that are nice points that aren't going to give me too many decimals. So I picked 2 because that gives me 4. 4 times an eighth gives me a negative half. And then I picked 4. 4 squared is 16 divided by 8. Okay, so I know that if this is the vertex, and if it's a sideways parabola, and if it's got a negative sign, I know it's going to actually open this way, sideways. So I don't know if you knew that, though. So you might assume that it's opening this way, but then you would want to maybe plug another point or two in here and see if you're right. In the interest of time, I'm going to just tell you that it's a sideways opening parabola. It's going to go open left because of that negative sign there. So I'm just going to go ahead and sketch it out. Okay, and then I don't think I did all of them because it takes a lot of our time. This one, your book is now taken to writing it in this way, where it's like y minus 1. I think you learned it in integrated 2 this way. Y equals a times x minus h squared plus k. I thought you learned it that way, so I always change it back to that. And then I find this is in graphing form now, so I'm going to go left 3 and up 1 for my, it's not a center, but it's my vertex. And then I'm just going to plug in another. I know that this is going to be an upward facing parabola, so I just need another point. So I was going to plug in 0, but then I got 3 squared. 0 plus 3 is 3. 3 squared is 9. I got 9/4, and I wasn't happy with that. So I said, what can I plug in to make this a little nicer? And I noticed if I just pick 1 for x, then I get 1 plus 3 is 4. 4 squared is 16. A fourth of 16 is 4 plus 1 is 5. So I got 1 comma 5. And then I just know there's symmetry, so I'm just going to. And you can still use this method, any parabolas that you come upon. So in the next one, the one that we're not going to do, you'll see this was moved, well, the y is squared again, so it's going to be a sideways parabola, and it would be moved, let's see, y, down 5, and right and left 2. So there's your center, and then you could plug some points in and come up with that. And you guys know you can also use Desmos, but you should just notice that there are parabolas besides the ones that just go face up and down. So we're going to do, I think, 6-8 and 6-9 quickly, and then I'll do part 2. Maybe we'll just do 6-8, and then I'll do part 2. So on 10-6-8, it says, oh no, we already did 6-8. We're going to do 6-9, sorry. The definition of a parabola. So what is a parabola? It says, now you will use your understanding of the definition of a parabola. Oh, sorry. It wanted us to use the definition of a parabola to create our own parabola. So you guys, we're going to go ahead and do a little construction of it, but I'm just going to tell you that going by this definition, it's a set of all points that are equidistant from a fixed line and a fixed point that's not on the line. What that means is that a parabola, it kind of reminds me a little bit of our other conic sections. It's equidistant. Every point on this parabola is equidistant from the focus and the directrix. So this is equal to this. And I know I haven't drawn a very nice example, so perhaps they won't look like they're equal. If I pick another point, that is going to equal that. Okay, that's what they're trying to say here. If I pick this point, that should equal that. So you can imagine that you could set your compass and you could construct one of these. It's a set of all points that are equidistant from the focus and the directrix. And you have to make a 90-degree angle, a perpendicular to the directrix. Okay, so that is the definition of a parabola. Oh, and there is something new that you don't know about. So you always have known that y equals a times x minus h squared plus k. And you know this is the stretch factor, right? Well, it turns out that since I don't think you've studied a focus and a directrix before. There's this distance, they call it the focal distance. This distance, we're going to call that c. Okay, that's some books, my old book that I used to teach out of called it P, the letter P, but this book calls it C, and that's going to probably throw me off a lot. But if you see me write it as P, it's the same thing. That distance and that distance are both C. Well, this would be negative C. Okay, so it turns out that the stretch factor is actually 1 over 4 times C, which C is the focal distance, the distance from the focus to the vertex. Okay, so now we've just kind of improved our equation of a parabola to, instead of A as a stretch factor, we're saying it's 1 over 4C times x minus h squared plus k. So now when we graph a parabola, we have extra stuff we can put on it. Now we can, the stretch factor, we can actually write it, we can put a focus in there, and we can put in a directrix. Now I think we'll, part 2, we'll do the next part, so this will be continued.